Welcome again. Today we look at balancing redox reactions, where our focus will be on balancing the redox reactions in acid solutions. Solutions where hydrogen ions are free. Do you know how to assign oxidation numbers? And if you don't know how to assign oxidation numbers, then you need to review this topic first before we can move ahead. So let's assume that we all know about how to assign oxidation numbers. Let's move in and look at this example. Here we see iron 2 going to iron 3. As it does so, its oxidation number changes from 2 to 3. There's a gain in oxidation number, meaning that iron is oxidized. Oxidation by loss of a single electron. Here, manganese with an oxidation number of 7 goes to the Mn2 plus ion, which has an oxidation number of 2. A fall in oxidation number of 5, which means that this is reduced by a gain of 5 electrons. This loss of 1 and gain of 5 is our first prompt in going about balancing this redox equation. And here we can see that the 5 electrons that are needed to reduce this ion comes from 5 Fe2 pluses, each of which will lose an electron to give us 5 Fe3 pluses. These 5 electrons will then combine here to form Mn2 positive. But the overall charge on each side, here it's 9 positive and here it is 17 positive. The good news for students of IB chemistry is that the types of reactions that you're asked to balance would always be solved by the addition of hydrogen and the addition of water, because the difference in charge is positive 8. We can add 8H plus to this side. But when we add H plus to this side, we need to add H's also to this side, which can come by adding 4H2O. 4 times 2 is 8 to balance the 8 hydrogens on this side. And then we also notice that 4 oxygens are balanced by these 4 oxygens, which then brings us to a final answer that looks something like this. And our redox equation in acid solution is now balanced. Let's review some of these steps. First, we considered what is oxidized and what is reduced. Then we used the changes in these oxidation numbers to help in determining how many electrons are going to move. And then we used that to add coefficients to the equation to correspond to the number of electrons. Here, we determined an oxidation number change from 2 to 3, which means loss of an electron. Oxidation is loss. Here, a change from 7 to 2, which means a gain of 5 electrons. So this 5 to 1 ratio can only be satisfied by using 5 Fe2 pluses, which gives 5 Fe3 pluses, with the 5 electrons that are lost being used to reduce MnO4 negative to Mn2 positive. For the redox reactions that we will get in acid solution, H plus must be added to counter this discrepancy. And here, 8 H pluses are added to this side to balance the charges. But then we also need to balance the atoms. And so water can be added to this side to balance the hydrogens, and then in so doing, we also balance the oxygens. We end up with our final answer that looks like this. Let's look at this example now. I has an oxidation number of 5 and goes here where the oxidation number becomes 0. This fall in oxidation number suggests that it's reduced. And if it's reduced, it means it would be gaining 5 electrons to move from oxidation number 5 to oxidation number 0. Here, this I negative goes from oxidation number -1 to oxidation number 0, an increase in oxidation number, meaning that it is oxidized. To be oxidized means that it would lose one electron. So here we see the relationship of 5 to 1, where one electron is lost here, but 5 are needed here. This immediately suggests that we need to multiply this by 5. And the result would look like this, where we have added 5I negative to provide the 5 electrons needed to reduce this I from oxidation number 5 to oxidation number 0. And we would justify why this I negative goes from oxidation number -1 to oxidation number 0. But once this is done, the equation is still not balanced because we have a negative charge on this side and a neutral charge on this side. To fix this, we must add 6 hydrogens to this side, which counterbalances the 6 negative charges and makes this side neutral. But in so doing, we've now added 6 H's. So to counterbalance for the 6 H's, we then add 3 H2O. And the H's are now balanced, the charges are now balanced, and we have added 3 oxygens, which balances with these 3 oxygens. Now you can try this. And let's take a look at the answer.